Here's the honest truth about Docker: you don't need 150 commands. You need about 20. The whole cheat sheet that actually matters fits on one screen, and the real skill isn't memorizing flags, it's knowing which command to reach for and when. So that's exactly what this is. A walkthrough of the 20-ish Docker commands you'll use every single day: pulling and building images, running containers, managing them, mounting volumes, reading logs, Docker compose, and cleaning up the mess. Every command on screen is real, current, and copy-pasteable. No dead flags, no old syntax. By the end you'll have the mental model for the whole workflow: build an image, run a container from it, watch it, get inside it, and tear it all down. There's a free written cheat sheet linked in the description with every command. Let's go. Everything in Docker starts with an image. An image is the frozen blueprint, a container is a running copy of it. So step 1 is getting images and building your own. To grab an existing image from Docker Hub, you pull it. Docker pull Nginx downloads the official Nginx image to your machine. To see what images you already have locally, run docker images. That lists every image, its tag, its ID, and its size. Now the command you'll run most as a developer: docker build. Docker build -t myapp. The -t names, or tags, the image, here we call it myapp. And that dot at the end? That's the build context. It means build using the Docker file in the current directory. People forget that dot constantly and then wonder why the build fails. The dot is the path Docker looks in. 2 more you'll want. To retag an image, say you want to mark a version: docker tag myapp 1.0. Now the same image also answers to myapp version 1.0. Tags are just labels pointing at an image. Tagging is cheap. And to delete an image you no longer need, docker rmi myapp, rmi, remove image. That frees the disk space back up. So that's images: pull to fetch, images to list, build -t to create, tag to label, rmi to remove. Now the star of the show, Docker run. This is how you turn an image into a live container, and it has a handful of flags you'll use constantly. The bare version, docker run Nginx, starts a container and attaches it to your terminal, so it takes over your prompt. That's fine for a quick look, but usually you want it in the background. Add -d, docker run -d Nginx, and it runs detached, handing your terminal straight back. -d is one you'll type reflexively. Next, ports. A container's ports are sealed off from your machine by default. To reach them you publish a port with -p, docker run -d-p8080:80 Nginx. Read that mapping as host:\container, traffic to port 8080 on your machine gets forwarded to port 80 inside the container. Get the order wrong and nothing connects, so remember: host first, container second. A running container gets a random name like nostalgic_Einstein unless you name it. Add --name web and you can refer to it as web from now on, much easier than copying container IDs. Need to pass configuration in. -e key equals value sets an environment variable inside the container, and you can stack as many -e flags as you need. And when you want a shell inside a container to poke around, combine -i and -t, docker run -it ubuntu bash. -it gives you an interactive terminal, and bash is the command to run, so you land at a prompt inside a fresh Ubuntu container. That -it bash combination is one you'll use forever. Once containers are running, you need to see them and control their lifecycle. This is where Docker PS comes in. Docker PS lists your running containers, their ID, image, status, ports, and name. But here's the catch that trips everyone up: PS only shows containers that are currently running. A container that exited won't appear. Add -a, docker PS -a, and now you see all containers, running and stopped. When you swear you started something and PS shows nothing, docker PS -a is the command that reveals the truth. Controlling them is simple, and this is where naming pays off. Docker stop web gracefully stops the container named web. Docker start web brings a stopped container back to life. Docker restart web does both, stop, then start, handy after a config change. And when you're truly done with it, Docker rm web deletes the container. One thing to remember, you generally have to stop a container before you can remove it, or Docker will refuse. So the lifecycle is, ps to see what's running, ps-a to see everything, stop and start to pause and resume, restart to bounce it, and rm to delete it for good. Containers are disposable. When you remove one, everything inside it is gone. So how do you keep data, or share files between your machine and a container? Volumes and mounts. There are two kinds. The first is a bind mount. You map a folder on your machine straight into the container. Docker run-v, $open paren pwd /app, node. That $pwd is your current working directory, and it maps to /app inside the container. Now any file you edit on your machine shows up instantly inside the container. This is how live-reload dev environments work. The second kind is a named volume. Docker manages the storage for you, which is what you want for things like databases. First created, Docker volume create data. Then mount it by name, Docker run-v data /app node. The difference from a bind mount is the left side. It's a volume name, not a path, and Docker keeps that data safe on disk even after the container is deleted. To see the named volumes you've created, Docker volume ls lists them all. Quick rule of thumb, bind mounts for your source code during development, named volumes for data you need to persist, like a database. When something breaks, and it will, these are the commands that tell you why. This is your debugging toolkit. Start with logs. Docker logs web dumps everything the container has printed to standard out and standard error. That alone solves most mysteries. But when you're actively watching a problem happen, add -f, Docker logs -f web, and it follows the logs live, streaming new lines as they appear, just like tail -f. -f is the one you'll lean on during a crash. Sometimes logs aren't enough and you need to be inside the running container. Docker exec-it web sh drops you into a shell in the container named web. Notice this is exec, not run. Run makes a new container, exec runs a command in one that's already going. That distinction matters. To get into a live container, it's always exec. Use sh if the image is minimal, bash if it has it. 2 more. Docker inspect web prints a giant blob of JSON with everything about the container, its network settings, mounts, environment, IP address, all of it. And Docker stats gives you a live dashboard of CPU and memory usage per container, like top for Docker. When a container is eating all your RAM, stats is where you look. Real apps aren't one container, they're a web server, a database, maybe a cache, all wired together. Managing that by hand with Docker run gets painful fast. That's what Docker Compose is for. And a quick note, it's Docker Compose, 2 words, the modern version 2 syntax. The old hyphenated Docker Compose is legacy, don't use it. You define all your services in one file called dockercompose.yaml, and then one command brings the whole stack up. Docker Compose up starts everything defined in that file. Add -d, Docker Compose up -d, and it all runs in the background, same idea as Docker run -d. This is the command that starts your entire application. When you're done, Docker Compose down stops and removes all of it, every container, in one shot. To check what's running in your Compose project, Docker Compose PS shows just this stack's containers. To watch the combined logs from every service at once, Docker Compose logs -f, that -f follows them live, just like on a single container. And if you changed a Docker file, Docker Compose build rebuilds your service images. So the Compose rhythm is, up -d to start the stack, PS to check it, logs -f to watch it, down to tear it all down. Once you're using Compose, you'll rarely type a long Docker run again. Docker is a disk space hog. Old images, stopped containers, dangling volumes, it all piles up quietly until you're out of space. So the last group is cleanup, and you should run these regularly. The workhorse is Docker System Prune. It removes stopped containers, unused networks, and dangling images in one command, the safe, everyday cleanup. It'll ask you to confirm first. When you want to be more aggressive, add -a, Docker System Prune -a, which also removes every image not currently used by a container. That reclaims serious space, but be careful, you'll re-download those images next time you need them. For targeted cleanup there are 3 focused commands. Docker Image Prune removes just dangling images, the untagged leftovers from builds. Docker Volume Prune deletes volumes that no container is using, and be careful here, that can be real data, so make sure nothing you need is unattached. And Docker Container Prune removes all stopped containers at once, so you don't have to RM them one by one. Simple habit, run Docker System Prune when things feel bloated, and reach for the specific prune commands when you want more control. Your disk will thank you. Let's zoom out, because that really is the whole toolkit. This is the 80-20 of Docker, the small set of commands that covers almost everything you'll actually do. Images, pull to fetch, build -t to create. Running, Docker run with -d to detach, -p to publish a port, -v to mount, and -name to name it. Managing, ps and ps-a to see them, stop and rm to control them. Debugging, logs-f to watch output, and exec-itsh to get a shell inside. Compose, up-d to start a whole stack, down to tear it down. And cleanup, Docker System Prune to reclaim your disk. That's it. Not 150 commands, about 20. Learn to reach for the right one at the right moment and you've got 90% of day-to-day Docker in your hands. Everything else you can look up when you actually need it. That's the Docker cheat sheet that actually matters, the 20 commands you'll reach for every day, and the mental model that ties them together. Build an image, run a container, watch it, get inside it, tear it down. Here's your next move, pick one container you run and try the flags you might have been skipping, -d to background it, -p to expose a port, exec-it to shell in. Muscle memory comes from typing them, not watching them. I put the full written cheat sheet in the description, every command on one page, free. And if you want to go deeper, there's a Docker and DevOps cheat sheet pack for $15, linked below, with the extended reference and real-world workflows. Subscribe if this made Docker click, and I'll see you in the next one.